Hi students, now let's start another new session on probability. In this chapter, I am going to discuss some questions based on marbles or balls. Different colored marbles are kept in a jar or basket or in a container, and we can pick up one at random or two or three. Many possibilities are there. We discuss one by one in a systematic manner. Now let us start with this question, simple one. A bag contains 4 green, 5 black, 3 yellow and 6 red marbles. If a marble is chosen at random, what is the probability that it is green or red is the question. Now see students, particularly the beginners, you understand this question in this way. Some marbles are there, right? All the marbles are kept in a jar or a basket or in a bag, and let us take the mixed. Now I need to choose 1, 2 or 3 at random, right? Means what happens here? Here it is a selection, not arrangement, right? So it is a combination. We are choosing something. So it should be taken as a selection. That is the first one, right? Now the second here, how many balls are picked up or how many marbles are picked up? That's very, very important. If they picked up only one marble, there is no question of choosing internally among them. Yes or no? Suppose 2 marbles are there. I don't know. Again, what happens there? The choosing between those 2 will come into picture. This is just like choosing cards only, or picking up cards from a standard deck of cards. Now let us take this question. Now how many balls are picked up? Only one marble is chosen at a random. What is the probability that it is green or red? Before doing this problem, let me clear this concept for you, especially for the beginners. Let us take, instead of giving what is the probability that it is green or red, suppose one marble is chosen at a random. What is the probability that that is a yellow ball is the question. In that case, what happens here? What is the probability that it is yellow ball means only one marble is chosen there. For that reason, now taking this yellow into consideration, you need to go for the probability. To go for probability, first of all, I should know what is the sample space, right? Now here, of course, I am choosing yellow ball, but from how many balls I am choosing in total? Total number of balls should be taken into consideration, right? Now, total number of balls is 5 plus 4 plus 3 plus 6. You should consider all at a time. So, it should be 4 plus 5 plus 3 plus 6. Now, it is 9, 10, 12 plus 6. It should be 18. You take it as 18 marbles. Now, sample space is 18 marbles. From this 18 marbles, I have to choose one ball. That too, the condition is the ball should be yellow ball. When it is coming for the favorable events, you should not consider other balls than yellow. Because I have to choose from yellow, means what happens here? Of course, the yellow balls are among these 18 balls only. There is no doubt about that. For that reason, total sample or sample space should be taken as 18. But while coming to the selection here, from these 3 only, right? From these 3 only, one ball will come, right? Or conceptually, this is from 3 balls, combination of one ball. When there is one ball chosen, there is no question of combination, right? When combination comes into picture, if it is 2 balls, it would be taken as combination. Even if you take this one with formula or conceptually as combination 3C1 from 3 balls only. You have to understand this one in this way. So 3C1 is nothing but 3. Alright. So this is 3. What is the probability of getting one yellow ball means? That should be 3 out of 18 possibilities. 3 out of 18 possibilities, right? Why is this 18 possibilities? Because I am choosing only one ball. Randomly I am choosing means how many times I can pick up? 18 times I should pick up because only one is picked up. Suppose 2 balls are picked up. So how many it should be? 18 combination of 2 comes into picture. Got the clarity? Right. So now it should be 3 by 18. Hope you must have understood this one. Now let us extend the concept for this question. What is this question? What is the probability that it is green or red? Now how to go for this one, students? What's the probability of getting green or red? So getting green, the probability of getting green is that should be 4 out of 18. This is the probability for green. Then probability of getting, what exactly they have asked for again? Red. Probability of getting red is 6 out of 18. Right? So now the question is getting green or red. Green or red means these two are mutually exclusive, right? So let us not use the words because I'm just giving you the basics. Simple way we can say either this or this. Either this or this means the condition is or, it should be plus. Should be plus. As simple as this one, right? So this is 4 out of 18 or 6 out of 18. That should be 10 by 18. Or it should be 5 by 9. What is the probability means? The probability should be 5 out of 9 cases. This is how you need to go for the questions. Got the idea, students, right? So this is the way. The beginners, you focus on this one, how to choose one marble. Now, if you want to continue the question in this way, for example, if bag contains 4 green, 5 black, 3 yellow and 6 red marbles, if 2 marbles are chosen, for example, if I take in this way, 2 marbles are chosen at random, what is the probability that those are, suppose the question is in this way, those are green or red. You try this question on your own. Simple way, students. Green or red means the same thing should happen. From green, I have to choose 2. And from red, I have to choose 2. But from how many marbles? 18 marbles. When 18 marbles, I am going to choose 2 at a time. 2 at a time means I don't know what is the color of those 2. For that reason, here it becomes getting green. Getting green is from 18 combination 2 here. As simple as this one, right? 18 combination 2, because I am going to choose 2 at a time. It should be 18 combination 2, and green balls, 4 green balls are there. Now, from these 4 green balls, I have to choose 2 at a time. While it is coming for the selection, you should not take 5, 3, 6 into consideration, because favorable events must be from green only. So now it should be 4 combination 2. Alright, next this is R 6 combination 2 divided by 18 combination 2. You have to go in this way. Got the clarity, students? Because this condition is R condition. Now let us have one more question based on this one, where AND condition should be there. If AND condition is there, how to go for this one? AND is obviously multiplication. How it could be if you take a AND condition. Now students, I kept the problem same, right? The information same, but change the question a little. Now you see, a bag contains 4 green, 5 black, 3 yellow, 6 red. That is it. Now, if 2 marbles are chosen at random, what is the probability that one is black and the other one is yellow? This is the question. Alright, one should be black and the other should be yellow. Now students, in this case, when 2 have chosen, but question is asked, one should be black, one should be yellow. How to handle this one? The same thing. Sample space is not going to be changed. Total possibility is not going to be changed, right? Our exhaustive events are not going to be changed. The number should be the same. What is that one? Since I am choosing 2, the sample space will be from how many? 4 plus 5, 9. Again 9, 18. 18 combination 2 only. Alright. So this will remain same. 18 combination 2. But here, one should be black and the other should be yellow. One is black and one is yellow means choosing of black, favorable events. How to choose now from black? So it should be from 5 combination 1 or simply 5 only. Alright, then after that what they have given, and the other is yellow. When other is yellow, how many are there? 3 are there, and means into. That should be. Alright, 3 yellow from 3 combination 1 or 3 divided by 18 combination 2. This is the way, students, right? Very clearly, simply they have done in this way. 5 combination 1 into 3 combination 1 divided by 18 combination 2. Got the clarity? Right. So further, let us extend that one, right? Let us increase the standard. Now, let us take it further, students. This question you observe, a bag contains, I kept some values same, 4 green, 5 black and 3 yellow. Only 3 colored marbles are there. Then followed by, if 3 are chosen at random, what is the probability that they have given 3 different questions for us? Alright, observe students, here also, I need to choose from all the balls. You have to consider all the balls, right? For what? Sample space. What is the sample space here? So how many are there? 4 green are there, right? Plus 5 black, plus 3 yellow. That should be 9, 10, 12. Total 12 marbles are there. Total is 12. Alright, so now from this 12, how many have to choose at a time? 3 at a time. Now 3 at a time means it should be 12 combination 3. These are all very simple questions, right? So now I should take 3 at a time. How many ways? 12 combination 3. But the first question you see, marbles are of different colors they have given. Alright, so when it is different colors, you should do in this way. Equal probability will be there. Equal probability means in the case of choosing. How is that? Now I have to take one green marble. The favorable events 4 combination 1 are 4. Right? And means into. The next black is 5 combination 1 and yellow, that should be 3 combination 1 divided by 12C3. As simple as this one. Got the idea? So here marbles are of different colors. Different colors means one should be green, one should be black and the other one must be yellow. Now it should be 4C1, 5C1, 3C1 or 4 into 5 into 3 divided by 12 combination 3 is the perfect way of doing the choosing the probability or taking the probability. Now go for the next one. The second one, exactly 2 black marbles is the question. What's the meaning of this one, students? Now I am picking up 3. Right? Now out of these 3, black should be 2. Exactly 2 black. It should be black, for example, or anything, whatever it may be. Now, don't be mistaken like it is an arrangement. Just for your understanding, I am writing in this way. It should be black. It can be any. It can be any. That's the meaning of that. Alright, so this is not permutation. This is not arrangement. This is the selection. For your understanding, as I told you, just have chosen in this way. 2 should be black. 1 can be any. Right? 2 should be black. 1 can be any. This is the meaning. Now how to take this one? 2 should be black. 2 should be black means I have to choose from this one only. Right? That should be, I am writing here, 5 combination 2. 2 should be black. And the remaining one can be green or yellow. You can take anything, whatever it may be, green or yellow. In this case, what happens? 4 plus 3, it is 7 combination 1 or simply 7 divided by 12C3. Remember this one. The beginner students particularly who are learning this concept should be very careful about this type of questions. Alright, so I have to choose 3 marbles at a time. 3 means sample space must be 12 combination 3. But the condition is out of 3, any 2 should be black and 1 should be or 1 can be any other color. So 2 should be black means for choosing favorable events, I should consider this 5 only. Alright, so from 5 I have to choose any Very simply that should be 5 combination 2 into this one can be any means green or yellow. Now it is 7 combination 1 divided by 12 combination 3. Hope you got the idea. Now you try this question, students. No yellow marble. How to go for this one? No yellow marble. Just think it over. No yellow marble. I am writing here. Here, simple way. No yellow marble means sample space is not going to be changed. This is very important, students, because anyway I have to pick up 3. Some students are getting confused. While counting the sample space also, they are not including yellow. That is wrong. That is wrong. Sample space will be 3. Will be the same, means 3 should be picked up at a time. Out of how many balls are the total here? Total how many we have counted? 12. So from 12 only. From 12 I am picking up any 3. While going for the sample space, here that is same. Here that is same. Sample space is 12 only. From 12 I am picking up any 3. 12C3. But in the numerator part, what it would be? Here no yellow ball. Yellow ball should not be there. Yellow marble should not be there. When yellow marble is not there, this is in this way. While going for the favorable events, you should not count yellow. We should not count yellow. It should be 4 plus 5, 9. From this 9 only. From this 9 combination 3. Got the idea? I am picking up 3 marbles. Means sample space is 3, 12 combination 3. If anybody is having this type of doubts, make it clear, make it, what you call this one, dispel that one, clear. So it is 12C3. While going for the choosing, the selection, here it should be done only from black and green, not from yellow. Means yellow should not be considered for the favorable events. Now clearly it should be 9C3 divided by 12C3. This is the way, students. Got the idea? Right. Let's move on to the next question. Take this question, students. It's a classic one. Right. And you can understand the complete concept of probability based on marbles or balls with this single question. Alright. So what exactly they have asked? A bag contains 1 dozen mangoes. 1/3 have become bad. If 3 mangoes are taken out at random, what is the probability that at least 1 mango picked up out of 3, right? At least 1 mango picked up is good. This is the question, right? Now listen to this one carefully, students. It's a good question. Even though those students who know the concept also, please concentrate on this one. How to go for this? Simple way, you see. Simple way in the sense, I'll make it very simple for you, right? So here, at least 1 mango. At least 1 is good. When the question of at least 1 is good, directly we can use a formula, right? But before using the formula, what is the comprehensive way? I'll tell you. After that, we go for a simple shortcut. What's the comprehensive way here, students? At least 1. Total 3 mangoes are taken out. Total 3. At least 1 should be good. What do you mean by at least 1 good? In the first class we have done, and even in permutation combination also we have done this type of questions, right? It is a little extension of that one. At least 1 good. At least 1 good means 1 or more than 1 should be good. Out of 3. Out of 3, the limit is 3 only, right? Out of the limit 3, 1 or more than 1 should be good. Means greater than or equal to 1 should be good. Means the very meaning of this one, 1 can be good, right? Or 2 can be good out of 3, or all the 3 can be good. This is the way. But students, here good and bad also there. 2 categories are there. When 2 categories are there, should be a little careful. How to start it further? Now 1 can be good, 2 can be good, or even 3 can be good. Now take all the conditions. If I want to take the conditions, first condition I am taking. So this is the detailed explanation, students. After that, in one step we can complete this question. But first you watch it carefully. Now here, 1 good. I am taking the case of 1 good. 1 good. This, right? What do you mean by 1 good? 1 good means 1 should be good and I'm writing and remaining 2, because total 3 I'm picking up, right? 1 should be good and remaining 2 should be bad. First case, right? Or here the condition is or second case I'm taking 2 can be good, means 2 good mangoes, and 2 good means 1 can be bad. Or the third possibility, all the 3 can be good, means in this case that should be 3 should be good and 0 bad. Need not consider this one. So total 3 ways I have to check. This is the perfect comprehensive way, means this is the concept of that. Now very clearly 1 good and 2 bad. How to take this one? 1 good. Now while going for the selection, the favorable events, you should clearly know how many good mangoes are there, how many bad. For that one they have given very clearly 12 mangoes are there. 1/3 have become bad. 1/3 means here 4 are bad. Remaining 8 should be good. Now how my selection goes? Here 1 good and 2 bad. 1 good I have to take from 8 here. 8C1 into. And means into. Now 2 bad. 2 bad means from 4 bad I have to take 4C2. Alright. Divided by it should be 12. 12. How many I am picking up here? 3 at a time. It should be 3 at a time. 12 C3. This is one case. This case is for 1 good and 2 bad. So here, because total 3 are there, at least 1 or more than 1. 1 good can be 8C1 into 4C2 divided by 12 combination 3. In the same way, the next one. What is the next one? 2 should be good, means from 8 I am taking 2 at a time. It should be 8 combination 2. I am writing here. Alright, just write it clearly. I'll write it clear for you. 8C2. And 1 should be bad. Bad should be taken from 4. 4C1 divided by 12C3. Alright, the next case you take 3 good and 0 bad. 3 good means from 8 only, 8 combination 3, nothing is there here, 0, take it out, divided by 12C3, right? Now what is my final answer? This or this or this, means finally you have to add up all the things, plus this, just do that. But see students, so before going to that, 8C1 into 4C2 divided by this, plus this will give me the final answer for, what is the question? At least 1 good. At least 1 good. This is the comprehensive way. Hope you must have understood this one. But observe students, in a competitive exam, for that matter, in any conventional exam also, otherwise they asked us to do in this way, we need not go for this method. This method is for you to understand the concept. Because once you have clear idea, only then you can attempt the questions, right? So now we will do the same question with a simple method. Let us take it as a shortcut, right? What is that? Instead of doing all these things to get at least 1 good, you need not do this one. Just take it out. Okay. Now keep this one same. What is this? Out of 12, 1/3 have become bad. 1/3 have become bad means it is 12 into 1 by 3. Now clearly 4 are bad, 8 are good. Now the question is, at least 1 mango picked up is good. Now students, always remember, probability of getting, I am writing here, probability of getting at least 1 good. At least 1 good should be taken as total, that is 1 minus probability of, what should be taken here? Think it over students. Probability of getting at least 1 good. At least 1 good means 1 minus all bad. 1 minus no good, right? 1 minus all bad. It should be probability of all bad. This is the way. This is a very, very important thing in probability. For that matter, in permutation combination also. I'm just explaining this one. Probability of at least one good is equal to total, that is 1. 1 minus probability of all bad. You can use this shortcut. But students, why this shortcut? This is important for you, right? So I teach you always in this way. You must have observed this one, because without base, don't take anything as shortcut. Why is this shortcut? Let us go in depth here. Now, this is the explanation for shortcut. This is for you, not for the examiner, right? This is the explanation for this simple shortcut. I'll give you clearly. Then after that, you can apply this one directly. What is this? See students, at least one good. At least one good out of 3. At least one good means, as we have discussed, greater than or equal to one good, right? Greater than or equal to 1 means one or more than one good. But before going for this one, what are the, so when you have picked up 3, what are the possibilities as far as good is concerned? That can be in this way: 0 good. 0 good means if you pick up 3, all can be bad. I'm taking all the possibilities as far as 3 are concerned. 0 can be good, or 1 can be good, or 2 can be good, or 3 can be good. Yes or no? Because I am picking up 3. As far as good is concerned, 0 can be good, or 1, or 2, or 3 can be good. Now, I need to find out at least one good. At least one good means 1 or more than 1. When it is the question of 1 or more than 1, I need to consider this only. 1 or more than 1. 1 or more than 1 means it can be 1 or 2 or 3. Yes or no? What are the total possibilities? These. This. Right. When I am picking up 3 at a time randomly, the question is what are the total possibilities as far as good is concerned? As far as good is concerned, 0 can be good because the competition is with bad. One more parameter is there. For that reason, 0 can be good, 1 can be good, 2 can be, or 3 can be. Got the clarity? Now, I need not all, I need at least 1 should be good. At least 1 means 1 or more than 1 should be good. 1 or more than 1 is good means 1 can be good, or 2 can be, or 3 can be. Yes or no? For that reason, I need to eliminate this 0. What is this 0? 0 good means total minus no good. Total minus no good. What do you mean by total minus no good? All are bad. 0 good. Everything should be bad. 0 good means everything is bad. So, total minus no good, or total minus all bad. This is the proof for that. Got it, student, right? Learn the concept in this way. Whatever the chapter may be, maybe it is in reasoning Shilhaism. I hope you must have watched all the videos of Shilhaism. Just watch that when I have given you the best out of the best methods in our country, right? If you learn this permutation combination, or probability, or averages, ratio proportion, or any other concept, input output in reasoning, or seating arrangement, puzzle, learn the basics, students. My basic idea is that one only. You should get that one. You should get the basics so that every student will be logically fit. You should be able to do something in the examination, because nowadays the examiner is very intelligent. Examiner is always intelligent, right? How they are doing? They are just twisting the questions. When the question is twisted, if you have the strong base, easily you can understand this one. My intention is to inculcate that quality in you. For that reason only, I am giving you these classes with this much clarity. Got it, students? Right. Now, next you go for, this is the proof anyway, total minus no good. Now, come back to the question here, how it should be. Total minus, now I am going for probability of at least one good. At least one good means total minus probability of all bad. It should be 1. Total means that is 1. 1 I am writing. Right? 1 minus all are bad. What is the probability of getting all or bad? Bad means this is 4. From these 4 only I have to consider. It should be 4, all 4 C3, all the 3 divided by how many are there here? 12 C3. Just simplify this one, students, right? It should be in this way. 1 minus 4C3 divided by 12C3. Right? So what is 4C3? 4C3 is nothing but 4 only. Right? 4 by, you just calculate 12C3. 12C3 you will get 220. Now if you simplify this one, it should be 1 by 55. Now my final answer for this question is 1 minus 1 by 55 is nothing but 54 by 55. Means what did you understand from this one? The probability of getting at least one good is 54 chances out of 55. What is the meaning of this one? For every 55 possibilities, 54 possibilities can be having at least one good. Because good population is more than that of the bad. Means almost it is close to 1. Almost close to 1. Means 54 out of 55 is the perfect way of doing the things. Hope you must have understood this one.